Welcome everyone to the February 2023 Talga Group quarterly investor webinar. Today we'll hear a presentation from Talga's Managing Director Mark Thompson about the group's recent updates. Following Mark's presentation, there will be a Q&A. Thank you to everyone who submitted a question ahead of time. You can also submit a question during the presentation through the Q&A function on Zoom. We've received quite a few questions, so if we don't get to the question that you've submitted, feel free to get in contact with us after the webinar at info@talgagroup.com. I now welcome Mark Thompson, Managing Director of Talga Group. Mark, over to you. I'll just ask you to unmute.
Hello, everyone. Thanks, Alex. Thanks, everyone, for joining us. Pleasure to be here. Not so freshly jet-lagged, back from a month on and off in Europe. For those of you wondering what this, I guess the format is at all is each quarter we're trying to do a webinar where we can just summarize the company fairly quickly, but it's really a forum to answer shareholder questions. So please, if you haven't already lobbed them into the email, you can lob them live now, I believe, and Alex will collate those and read them out. And in response to previous criticisms of timing, I won't try and preempt things too much in the presentation. We obviously can't put in much new things in things like presentations that are already ASX disclosed, but we will want to provide lots of time for speaking to your questions afterwards. Let's see if this works okay. So for those of you that are new to Talga, because we do have just under 12,000 shareholders, but many of you have been with us for a long time. And but those that are new, we make battery and advanced materials. We have our own graphite resources in Sweden. Probably we're a bit distinguished because we are making the final products that are being sold to manufacturers of batteries. So it's a mine to anode or mine to customer model, which is quite rare actually in the advanced chemical industry with battery materials. It would be the equivalent of a lithium miner perhaps making an actual cathode material. So it's not normally done. But in this way, we capture all the margins. We own our own coating and production and process technology. So we have adapted things from different industries, food, pharmaceuticals, as well as the highest quality battery production materials around the world. And we have transferred those now to Europe. And we have very unique graphite sources themselves, very small battery-sized flakes, more akin to being an anode mine rather than an industrial mine. And we're on 100% sustainable power. So we produce very green products from our high-grade mine and with special low cost and low CO2 emission power sources. And in the right here behind our EVA plant in Luleå in Sweden, you can see what is the start of the green steels, these low CO2 shift from steel production over to hydrogen. So it's a hub for green energy and production of cleaner materials. And of course, we are in Europe. We're not based in Australia or Africa or North America or somewhere, but in our case, we have direct road or rail directly to our customers. The corporate office is in Perth. We have 60 staff now, mostly in Europe. Up in Kiruna is the mining resource area. Luleå is the anode refinery area. In Cambridge, UK, we've just announced our new battery centre of excellence there, which is an substantial expansion of our product technology capability and centre. And in Rudolstadt, Germany, near Erfurt in central Germany, it's about halfway between Frankfurt and Dresden. That's where we've been pilot scale and developing our process technologies, metallurgical capabilities. And around those, we obviously have got other partnerships with groups to toll treat things that we're not doing ourselves. We've just opened actually an office in Stockholm for corporate growth there in Sweden, and part of just the maturing of the company. And in Japan, our chief scientist and technology officer until recently, he's was living in Japan, and we have done a lot of scale up and development of our technologies on the processing side in Japan before bringing them over. And of course, Japan is the home of the original, a lot of original lithium-ion technology work that was done, particularly on the scale up. Our mission, as ever, has a purpose. It is both corporate for shareholders, but also to enable more sustainable products in the world that use graphitic carbon materials. So in the past, this was graphene. We still make graphene and have a whole range of graphene products, but we are also now developing projects specifically for battery materials. The flow sheet looks a bit like this. This is just a rough summary of what Talga as a company does. On the left-hand side, starting from graphite input or carbon input, we have our special ore bodies, not just one, but several in Sweden. And we also now have the potential to use recycled materials coming into our processing stream, where we have process technology across both of those areas. And then that hits what we call the refining stage. This is more of the deep downstream, so purification, shaping, scene. And then you get into what we call Talga products, where we've got brand names. Talnode is the battery anode, obviously, to me, and Talphene, which are more graphene related products. And there's quite a bit of overlap actually sometimes in the morphology of those products. There's also some overlap in that byproducts of Talnode anode production for batteries can be used in the production of graphene type materials. And likewise, some of the graphene materials can be used up to help out with the battery materials. So in the past, we were looking at mostly the coatings, composites, and construction markets for graphene. They're still all alive and being worked on, but predominantly the fast growth and the rapid commercialization and the underwriting of the financing of the project is all based around battery materials, predominantly Talnode C, but growingly silicon, which I'll talk about later, and conductive additives, which are essentially, people may not realize, but up to about 3% of battery electrode materials are carbon black and carbon nanotubes. These are sprinkled in to add conductivity properties into electrodes and change their conductivity, obviously, or the inverse, which is a resistivity. So yeah, it's an interesting, very established market there. Anode industry continues to grow. You can see 2022 where we are. The outlook for anode growth is massive. You're used to seeing a lot of hockey stick type shapes for battery materials, but yeah, I would say that the graphite's only just starting to be recognized for what it is. EV sales are now kicking in harder. Battery cell demand is kicking in harder. There's been a lot of flexibility with different sources of graphite, both synthetically or artificial and natural, have been able to get scooped up. And now you're seeing places like China become a net importer for the first time of natural graphite. The preferred size for making anodes is quite small. Anode particles for batteries are actually very small. They range from 5-6 micron up to just under 20 micron. But the trend is towards the smaller sizes for faster charge kinetics and things like that. So around 10 micron or less is premium sort of products. And certainly there's a big deficit. So you can look for benchmark, look for row motion, look for fast markets data. They tend to cover a lot of that technical side of the industry. But there's a huge shortfall expected, including in Europe, where the planned battery capacity now exceeds 1 terawatt hour per annum. Within the next 7 years, it reaches that point, which will require over 1.3 million tonnes of anode per annum, of graphite anode per annum. And that is in contrast to our stage 1 project, which makes only just under 20,000 tonnes per year, and an expanded NISCA project does 100,000 tonnes per year. So even following our 5 times expansion of our stage 1 project, we would be less than 10% of European demand alone. And of course, this isn't allowing for other growth markets like North America, and indeed back into other parts of, shall we say, Eastern Europe and back into Asia. So anyway, lots of companies setting up there. So the important thing is that Europe has got a lot of growth planned factories and existing factories that are now cranking up there. So the growth is all in front of us. Our main product, Talnode C, which is qualifying with numerous companies now It's quite deep into qualifying. It's at a B, and with some groups even a C stage. Is characterized compared to other materials as being quite energy dense. It's got quite high capacity, works really well at lower temperatures in particular. It's got very low resistance. So yeah, it works really well as a blend with synthetic for EVs, or it can be used 100% for some EVs, but also other markets as well, like ESS, stationary storage, or what's called the 3C market, which is quite exciting in itself because it's things that have also got interesting growth trajectories, like power tools, things like carpet cleaning robots and vacuum cleaners and drills and all sorts of devices. More and more things are getting electrified every day. And drones, all sorts of drones of different sizes, underwater drones, as well as aerial drones. So there's just a vast range of electrification going on. And the interesting thing about those non-auto markets is they tend to be smaller, they struggle to get access to supply, and so the pricing's often a lot better. And there's no shortage of demand for both EVs and all across the other segments as well. So anode/battery material companies like ourselves can sort of pick and choose where you're strategically best placed to be. Offtake. So we're progressing, obviously, offtakes that will underwrite our financing, where we've got targeted debt ratios on building the project. It's a $480–500 million US project to build both the anode refinery production and the mine itself and the concentrator. We have announced publicly with ACC, was October last year, and we thought, based on both companies agreed that by the end of November we'd be in position to sign off on that. It's taken a bit longer than we thought. Automotive is notorious for both wanting all sorts of commitments, but also chopping and changing a little bit. But anyway, we're still active. The status of that is still active. When there's a change to that, we will tell you. But obviously, we're working very hard to continue working with ACC to get that over the line. ACC, of course, is a co-owned company by Mercedes-Benz, Stellantis, and Saft. Saft is Total Energy, and they've got previous battery production facilities in France and other parts of Europe. Stellantis is a whole bunch of global automotive brands, including Maserati, Fiat, Chrysler, whole heap Jeep in North America predominantly, but also globally. So a whole bunch of different brands there, and Mercedes. And so when you qualify material into the offtakes we're trying to do, which have got very specific terms, they're not like raw material offtakes where you just promise to deliver something in future to a spec and anyone can sign it up and it's subject to future qualifying. We're actually qualifying the materials. And so we're getting close to a more serious sort of agreement. And I apologize, it's taken longer than neither company were expecting, but the details of this are, it's a big contract. And so it's worth spending time on for both of our sakes. But it's specific to a project which will be like a model. So it's quite advanced. And likewise with Verkor, we're pleased to work with them. We'll be able to provide more details when we finish executing the binding terms of that, or finish negotiating. But they're a big supplier to Renault. And so it fits with Talga's potential to fund the project. You're in European Union type banking, sitting within the European Union countries like Sweden, and having European car companies and battery makers who are tied into this entire network of Green Deal that's happening in Europe. We've built the first coated anode plant already, which is operating in Europe, and I'm not sure if there's many doing it at all, if in North America at this stage, where you're not only purifying material, but doing the coating and everything with in-house technology. So just to be clear, this is what would be called CSPG by other people's nomenclature. In the industry, it's usually raw graphite. If it's shaped and purified, that's still called graphite. Once it's coated, it's just called anode. We have our own in-house way we do quality control with battery laboratories there. We're ISO certified. We get audited by our customers. Automotive companies have been coming up, and cell makers for a while now to Sweden and looking at both the mine operation when it was going and also the trial mine, but also the EVA plant. It's really exciting that they get to see it and get to see our other facilities as well in Cambridge and also Germany, and understand that we're quite well prepared for transitioning to commercial scale production and continuing to ramp that up. We hope to be in position to start construction on the groundworks of this later on this year. We'll have some more details about that soon. So the idea is to be in commercial production of the full-scale plant, which lies about 1 kilometre away from here, later on in 2024. Sometimes people ask about the qualification process, this ABCD process, the automotive. The difference between anodes and things like lithium and cathode materials is that they're all chemical based on metal. So as long as you produce something to a spec metal, then people will buy it off you. The difference with anodes and why it takes longer than people think is the anode has to be tried because it's not just about purity, it's also about the internal crystallinity, and it's also about the way the shape of the product works. So they have to physically test it. And if you test it from a lab, you then need a bigger sample coming from a pilot plant. When you finish that, they say, well, that's okay. We now need to see it coming from a continuous, semi-automated flow. And then we need tons of that material. And then we need, 50 tons or 100 tons coming from your first actual production. So it's a bit catch-22 or cart before the horse, but where they actually, to finalize qualification, they need you to have already invested and be producing quite large scale samples. So that's why it's very hard for people to get into the anode production business. But if you do crack it, obviously the margins are there and the scale for you to grow and be one of the few companies outside of Asia to be able to make anodes is quite a big opportunity. And that's what Talga's strategically designing for. So the EVA, we can do A's from the laboratory, but the B and C sample come from the EVA plant. This is, if you don't have something like this of this scale, you're not actually going to get to the point of a serious offtake with a serious end user or a customer where you're capturing that entire thing. You'll be using intermediaries instead, and they'll be qualifying the material themselves, and you'll be getting more of a raw material price. Silicon we've mentioned lately because it's sort of growing quite quickly. So you need silicon you don't need silicon. There's an interest in silicon. We have been developing silicon anode products for several years now. We're in our Gen 2 version. It contains about 50% silicon. The rest is graphite and graphene, which is what helps make the cope with the swelling of silicon. When it gets charged and discharged, it tends to swell and crack, and so it's not easily usable in batteries. So our approach has been a very practical one, where we can scale things up. We've been on the right-hand side at the top right here, you can see just a small little fraction of our pilot plant, which we're now extending some of the tech we're using. Obviously, we can't show the nice stainless steel groovy bits of kit for commercial reasons, but it's expanding really well. And I've just been in Germany recently. Team there's done a fantastic job. Commissioning is well underway, and we'll have a lot more to say about that. Why we would take on the ambition of an added project instead of just what we're doing in Sweden is because obviously we've had very positive outcomes of negotiations with customers that have been testing the material, and there's some targets for commercializing of this material. So we're looking at sites where we want to build a refinery to basically start producing commercial quantities of Talnode Si, which the beauty of this is it actually is byproducts of our Swedish anode making for Talnode C, and you can use those byproducts, take them down to Germany, smash them up, and build this much more complex silicon particle, which has got a much higher price point, but has got a certain demand in the market. What is that demand? Well, look, we know silicon's like an energy booster in the, I guess, going back a long time in combustion engines, people would always be trying to put a little pill in the tank to boost things up. In lithium-ion technology, it's silicon. You dope a little bit of silicon into the graphite and you can boost its energy. You get most of the energy boost from small amounts that you put in at the beginning, and after a while that sort of tops out. So we would provide a product that's a 50% silicon containing particle. Our customers would then sprinkle that and mix it into their graphite to dilute it down to what balance they want, what sort of energy density they want. So our primary particle does about 1,800 milliamp hours per gram of energy density, which is about 5 times higher than graphite alone. But the customers don't need it that high, and it has other repercussions around longevity. So you want to sort of balance that up and put in as much as you need to boost performance, but while retaining the length of cycle life and other things you need. In conjunction with our forecasters and industry participants, we expect about 5% of the anode market will contain silicon, or by volume, over the next couple of years. It can go into different battery chemistries, but the 4680 and NCM 811s are a pretty good spot for it, if you know what I mean. And in fact, it's quite interesting that in the Biden's, the USA Inflation Reduction Act, that they've actually put aside money specifically for silicon anode production support and subsidies in North America. And Europe, we're expecting to, well, Europe has scope for also supporting silicon anode projects through what are called the IPCEIs, the Projects of Common Economic Interest, and other grants. So yeah, I think it's going to be a growing space. We invested early in it to be an adjunct. It makes our graphite production more efficient to use any byproducts in the silicon product. We have scientists that specialize in silicon, and we know, you know, the feasibility of it. Obviously, we've been working on for a while, both in the UK and now transferring that into the German space, and it's looking good in lots of ways. We'll just have more to talk about it once we close some deals out. And recycling seems to have surprised a few people recently. We've actually had this reload study public on using spent lithium-ion batteries. So not, as you can see here on the left, this is an unused anode. So this is you know, trimming waste from the battery cell making process. That material is quite pure, and taking that and turning it back into battery materials is possible. But once a battery has been used and intercalated with lithium, and you get all these compounds forming deep within it, most people that are recycling batteries produce this black mass, of which graphite is one part. When you take that graphite out, it's full of sulfurous compounds and hot carbonates and all sorts of, frankly, horrible, nasty things that currently no one is showing a commercial way of how to use it. We are studying and working on taking that material, putting it through some of our graphene processing type technology, and seeing if we can use that in materials. And the reason why that can work for us versus others, and look, I'm sure some others may crack this eventually, but there are good reasons for suggesting that it may never be cracked for large scale battery recycling, because to the material you put into a battery, the graphite, has to be extremely pure and work to a very, very high efficiency. And to recycle things back into it, by the time you put all the chemical or thermal energy in to do that, to clean it up, you've probably emitted more CO2 than what you're saving by doing the recycling, if you know what I mean. So you'd be better off getting our material from Sweden and just using that straight up, and that would be kinder to the environment than the recycling. But there will be a lot of volume from recycling. So it's something it's incumbent on us all to be responsible for researching and working on if we can use it. But I think using it for other things like silicon, for example, is interesting, because a normal lithium-ion battery, the graphite's doing the job of intercalating the electrons. It holds like a sponge, it holds all the energy and then releases it. But when you get into other battery materials like silicon, you can use the graphite. It doesn't have to lithiate. It doesn't have to hold energy. It can be a structural framework. So there are ways that we could be able to use recycled material for battery materials, but they're not standard lithiation type graphite purposes. So yeah, it's part of our technology to be able to work on that. And I'm excited about that. I think it suits Europe. It suits us as a company. It can suit economics, obviously, if it works out okay. So there's a lot of benefits to it, and our partners all, of course, are excited by that as well. Does it ever catch up with the volumes of graphite required for the market? No, it probably never catches up, because you're decades away from having enough volume of batteries to reach steady state, I guess, in the world. So literally decades away. And before then, you need tens of millions of tons of graphite anode. And second point is, as I said, there'll be losses, and there'll also be a lot of material that can't be used. So you'll never ever catch up with the overall volume, but you should be trying to use what you can. So it's good part of what we're doing. Regarding the permits for the mine, the environmental hearing is nearing to a close. I was up there for the first few days. Since then, the team's doing a great job. I managed to catch up with most people around the court process that needed to be caught up with. And yeah, it's been really great to reach this stage after so many years. So we're expecting that to conclude in just over a week, and they will give us then a date of when they expect to publish the decision, which is commonly 6 to 8 weeks, later, but we just don't know what date they're going to give us. So in that time, they're going to be actually writing up their decision and writing up the conditions they want as part of whatever decision they're making. Obviously, conditions if it's positive, and if it's not positive, I guess they don't need to. We also are having some pretty good advancements on the building permit for the Luleå site. We put those in last year. This is for the refinery, and that building permit is maturing, and that would enable us to, we're awaiting various developments of that to enable us to maybe start construction of the Anode refinery later on this year. And of course, we have already applications in to expand. The existing mine environmental plan, Natura 2000, and the exploitation permit, they'll all sort of be triggered together by the environmental hearing. That is just for North South. The Niska stuff is down the track, and because of our customer demands, we have to look at looking at whether that's still the appropriate size or not, or whether it needs to be larger. But look, things are all coming together, so that the permitting for the mine and the refinery is all coming together, and we've got reason to be confident that things will go well. Our team has done a fantastic job in putting up a strong case. Ultimately, it's up to the authorities to decide, but we've certainly put up what looks to be a strong case in a project that is a good idea for Europe, I would say, and that's helped attract funding. We've had some appraisal already from the European Investment Bank for up to 300 million euros, plus a whole collection, as you can see on the right, of different commercial banks, export credit agencies, Swedish, Nordic, and Swiss, and more remote banks and institutions coming together to do diligence on the project. It's at quite an advanced stage right now, to be honest, and a lot of these groups are funding some of our customers as well. So they're quite knowledgeable about what's going on. And yeah, we're targeting a sort of debt gearing. So our finance strategy is to have a majority of debt. Now, 2 or 3 years ago, you couldn't probably do that. You probably had to sell equity in the project down, but now the environment's matured to the point where we can probably have a decent level of debt, and then that will leave a gap of equity to be done. Not just equity in the headco, there's some different formats that we can pursue, which is I'll talk about in a little bit as well. But anyway, that's maturing. Independent reports on the technical side of the project and the market, and so many things around the finance has been very capably run by Melissa, our CFO, and also with Bernvoir, our advisors in that area, doing a great job. On the environmental side, we've been doing, the team also just got a fantastic group of people up there. Liz up in Kiruna and the rest of the team in Luleå have been having a lot of dialogues. We publish things regularly over there. We've got obviously Swedish language website, and we interact as much as we can, including with the reindeer herding cooperatives. And there's lots of dialogues that are open in that area at the moment. And of course, the huge amounts of permits you need to operate sustainably in Europe, both because it's the right thing to do and because our customers demand it. As Europe the other day actually basically outlawed internal combustion engines from 2035 being built in Europe, they've got goals towards net zero individually under the Paris Agreement, but also most companies realise that their current imports of existing anode materials got really high CO2 and are quite dirty, especially by the time they're delivered, including shipping. So we provide a very clean version of that, and we've been audited. We've had some extremely large companies come up to site to audit our claims about our CO2 emissions being very low and being world leading, and looking at the power supply being 100% sustainable hydro, which it is, and we've been given a lot of support or ticks from the work we've done so far. So it's credit to all of our team. And then that feeds into Europe's time is arising, where they are going to not just respond to the Inflation Reduction Act in the USA, but they already had an existing Green Deal. They already had huge amount, I think about 250 billion euros set aside for sort of technology and electrification of Europe. They're about to publish the Critical Raw Materials Act in the next few weeks. We've been doing some lobbying and representations in Brussels and tried to educate the legislators as much as possible, not just about our company, which I think we've raised our profile quite well. We're quite well recognised now, I'd say, across the European legislative network, but also to teach them about graphite, recycling, how it works, what the existing markets, the technologies, the processes, the safety, the transport, the handling, all these sorts of things. Graphite, particularly natural graphite, has been highlighted in recent times by head of the commission, and of course the president has talked about the Net Zero Industry Act, which is also coming out. So what you've got is a big framework called the Green Deal, and within that they're now setting up individual acts and legislations to enable access to funding, shortening permit times, specifying recyclability. All these sorts of things will come into effect. And yeah, it's going to be very, very exciting for us to see what impacts of those will be positive. There could be some negative ones, but we're excited about the opportunities for funding of our future growth being available through some of these streams. We're also excited about how it will change or possibly accelerate the uptake by local battery manufacturers of local materials, of which we own, the largest supply of natural graphite in Europe. So the way this all interacts is going to be very good. Here on the right, you can see Ebba Busch, who's the Minister for Energy, but also the Deputy Prime Minister of Sweden, visiting our booth. We were one of a few companies invited to be present when the EU met up in Sweden recently, which is near our Vittangi project. And in fact, the entire European Union leaders all came up, and Sweden is taking its turn to essentially run the EU Commission for the next year. So that's all come together really nicely, and we've had really great response from them learning about the project and our material. So just coming to an end now on our partnerships still existing across a network of all sorts of companies that probably there's some changes as we mature and as the financing regime for the project matures, as the products and the commercialization all matures, where the focus is on things continues to shift positively forward. But yeah, we've got essentially a history of working with top tier companies and integrating with them about what they want. So what's coming up? The decision on the mine permit obviously is a big thing that people want to know about. Secondly, tying in with that then is triggering the conclusion of project financing and the potential commencement of construction later on this year, of starting at the refinery and probably the mine after that, assuming all goes well, subject to permit, subject. Commercial agreements continuing. We continue to have more customers than we can possibly handle, but getting deeper and deeper into the details of their ramp-ups and model qualifications and what's happening with the material. So the validation, I would say over the last year, one of the most significant things has been the validation of our material by so many customers, and now, the deep plans of integrating our material into their supply chains coming up. So essentially you won't see nothing yet. Like, a lot of the demand that was going to hit anodes was forecast to be around 25, and that's when we're planning to come into production, more full scale. And that is, the exciting times are actually in the next couple of years now, after all this investment in years in the past. I think silicon's exciting, obviously, as well. Very excited about being able to do something that doesn't actually rely on the mine. We can use graphite from the mine, obviously, but we can use also graphite from other sources to make that material if we want. We've got some exciting developments in silicon, both in the near term, commercialization potential, looking at feasibility study, but also in going to our Gen 3 material, and also other ways of making silicon anode material that I think would revolutionize the entire world. So I've made comments like that over the last few years. That work is still all ongoing and still exciting and continuing positively. Haven't had any roadblocks on that yet. Next gen technologies like solid state, they're all layered up. When people need material, we'll have something to sell them, basically. And we have to look at the way we go about expanding the project, not just from north to south, its potential to expand there, but the way Niska can be brought on stream when it comes to our own mines, but also expanding, beyond what the Niska plan is, and potentially realizing that we own anode production technology and battery material technology that is transferable to other countries. So in other words, it doesn't necessarily have to be fed from our own sources. We have got quite advanced know-how now, similar to the giant chemical conglomerates of Asia. And there's nothing to say we couldn't compete by having purely downstream processing capability built in other areas as well. Although that's that's down the road. That's we've got to walk before we can run sort of thing. But it's something to be aware of, is that when we talk about being a technology company that happens to own its own mine, it doesn't mean that we have to use the mine for 100% of what we do. There's all sorts of other opportunities. At the end of the day, we choose the pathways that are the most robust and most exciting, where we've got massive advantages, where we've got a deep and wide moat around our tech and what we do, and can capture most of the margins. But yeah, it's probably more, it's full of variety beyond what you can see published at the moment. Just finalise on saying, yep, share price doing pretty well. We had, obviously, last year was a tough year for the market. Market cap's just under 600 million Aussie now, still a minnow in the world. To be honest, after 13 years in July it will be since we've been listed, 330 million shares on issue and a few options, cash of 23 mil. Yes, we've got a good burn rate because we're doing a lot. We're not sitting around just making plans. We're actually investing in equipment and people to actually go out and do what we said we're going to do. And pending these permits, we're in a position to actually start constructing things. So yeah, we're in actually a project build stage. You've got to place orders for equipment years ahead. You've got to get around the chip shortages, so-called chip shortages, and you've got to get in line for some of the equipment you want. And the modern world, there's a fight on. So we invest in, I would say we invest very well. And when times are tough, we slow things down. When times are good, we speed up. But we're coming to where everything that you was holding us back is all about to sort of be resolved. Really good share register. Pretty much all the major top shareholders participated in the last placement, which was back in the tough times, mid-June last year. So we only did a small amount there, but yeah, up around $1.70-ish today. So we're still, of course, we're cheap. So I'd better leave it there. Thank you very much. And I'll throw to questions now. Hopefully we've got a good amount of time left.
Thank you, Mark, for the presentation and for updating everyone on the group's activities. So we're now going to move to the Q&A portion of today's session. So once again, thank you to everyone who submitted a question ahead of time or through the Q&A function on Zoom. So the first question I want to ask, Mark, is regarding Talnode C and the EVA plant. What percentage of the roughly 20 companies qualifying Talnode C appear to be seriously interested in an offtake agreement?
Well, there's multiple, there's a lot. Well, we've only got room for a few because in the first stage, 20,000 tons of anode, that gets choose out. So you actually only need 2 or 3 customers for your offtake. And then there's more, potential expansions down the road. So they're all at different stages of both their testing and their own corporate development, and in different sort of countries. So I wouldn't give an exact number, but they're all testing the material with a view to they want a supply of it. It's just all a matter of time about when they come in and at what level. But yeah, it's there's only going to be room for some, and the earlier movers obviously will get certain deals, and anyone else wanting something further down the track is going to struggle to get volumes from us or anyone, and then that will continue to grow, and that's why prices are heading up again.
Could you just put a little bit of color into into talking about the average time it takes most customers to qualify an anode material?
A lot of customers, even some cell makers that are starting up, they're actually either at capacity, their own testing facilities are at capacity, or they don't have them as advanced as what they want, and they don't have enough volume, and it's got to spill over, and they've got to have materials sent somewhere else in the world or to another person, or they want us to make the anodes for them and return them or even to make an entire cell for them and send them back for testing. So they all vary a lot. There's nothing specific, but you can certainly say that it's the first 6 to 12 months is a sample and wanting optimizations, talking about, kilos of material, and then you're looking at least another year for them to get to the point where they're probably getting close to an agreement. So it's a fairly long process, mostly because of they cycle. So you build batteries, you put them in machines that charge and discharge them. That's called cycling. And so if you want to duplicate what is 8 years or 10 years of life in a car, in the battery use, they have to cycle it for, say, 3 months. Then they get some results, and then they collate them. Then they've got to come back to you and you discuss the results, and if there's any changes or things needed, things like that. So that qualification, that's why the qualification process takes a long time. Now, there's some groups that sort of try and supercharge that process and have material, machines that can purportedly, generate answers a lot, deeper into the future. But most people don't have either access to those machines, or they don't sort of trust them yet. And they want to do things the slower way. So it's a slow process, multi-years for most of them. So some of those are starting to mature now with us, and others are just starting out.
Great, thanks. Let's go up the road back to Kirina, or just outside Vittangi. What's the timeline for the resource upgrade?
Resource upgrade, yeah, apologies for that. We said we'd put that out by the end of last year, because last year was, capital market pretty constrained and pretty depressing time. We actually slowed things down a lot towards the end of the year. So with that got included in the slowdown. It's nearing completion now. We're cranking it back up again. The reason is it's not actually a vital part of our plans right now. So the resource upgrade is just something we need to keep doing for future planning, like NISCA scale planning, but it just wasn't so vital to have funds diverted to that where we're building the project and going through what we're doing now with the permits and stuff like that. So it made more sense to delay it a little bit. But yeah, it's not far away now. That's all I should really say about it. We drilled the NISCA link area. So it's not like we've gone around the whole 15 kilometers and we're going to do some ginormous upgrade of the whole thing. It was specifically targeted to the area between the two NISCAs. And because that isn't in the existing mine plan for Nunswear South, it was something that we decided to just take off the priority list. And but the results will come through very soon, as will the results of the exploration that we did. But we also didn't prioritise results for continuing to expand our resources in the Vittangi area generally. But yeah, you'll see them soon. But the project, there's nothing we're doing right now that relies on that. It's something that's, all our layering up for the future.
Are there any current plans for further drilling in the near future?
Yeah, there's not detailed plans, to be honest, because as I said, the priority is to get into production, and we've got our production plans are based on a 2 million tonne ore reserve out of the 30 million tonne current resource. So we're more interested at the moment on drilling that could alter the mine plan or output in the short term, and the shortest term would be to do something in Nunswear South. Once it's pending that it's permitted, then doing something there would be more advantageous in the short term, rather than continuing to build tonnes that you're not going to use for 8 years or 10 years elsewhere around the dome. But there is an argument to be made that if the financial situation was right and I had the money, I would just drill out the whole dome and drill out the entire exploration target, and you'd have, as per the exploration target, up to several 100 million tonnes developed for making a giant, plan. So we do have plans to go big and to be larger, but it's just about timing when you do that, when you incur that expense. Drilling is done by diamond drilling up there mostly, not RC, and it's not cheap, and it takes some resources. And so if we don't really need to for anything specific as part of the planning, the exploitation permits we need to put in at different times, then we haven't really gone ahead too much. But certainly if I have the money, you all know I love drilling, I love exploration. I'll go out and do more of it if I can.
Right. I had a few questions come in regarding the permits. Just one clarification on timing. So the decision on permits will be made. Let me start again. The court hearing concludes on the 23rd of February, but will we know a decision on that day?
No. the way the process works is that when they finish the hearing, they will give us a date when they will give you the decision. So the hearing part will be finished and they will inform us and we will inform you what date they expect to publish the decision.
Right.
So it's called a court, but in reality, it's more like a hearing that is after several years of they've reviewed all the meter-high documents of paperwork, objection periods, gone up to site, had town hall meetings and hearings locally. And so this is the last stage to gather up it's part of the process. And then they will, but then they have to write that up, what their decision's going to be. So it needs some time to write it up and publish. And we don't get forewarning of that. I think we will get told when they publish the decision will probably get published in Sweden at the same time as we're told. And then we will obviously convey it to you as soon as possible. So yeah, we'll find out what the date is on February 23rd, 24th when they finish that.
Right. Should a permit not be granted or successful, how do you see the future prospects of the company?
Yeah, well, we've got multiple mitigations around that. So not in priority, but of course, first we can appeal a decision that's made, so we can go back to the court and try and sort out whatever would be their reason for not granting a permit. Secondly, you can apply for more permits, like different permits. Obviously, there'd be a time frame around that, but there's nothing to stop you doing it both for Vittangi, but also Jalkunen and Ratiavi, our other projects. So there's still the potential to go ahead with those. And thirdly, of course, we have our silicon anode business, which is looking good. And fourthly, we have been doing some work with customers that want us to not only blend, but make anodes from synthetic materials. And so we can use our anode technology to use other graphite sources potentially. Now, we've never pursued that in the past because we're happy. We know that the maximum in sustainability and economic performance is from our own deposit. But if we literally were cut off, frankly, we would still become quite a sizable, successful company, I think, just from our downstream processing technology. And obviously then that would expand globally. We wouldn't be exactly tied into Europe. We'd still be operating there, but we'd probably also expand into other countries or other continents, I should say. And so yeah, there's a whole group of mitigations there. If there's any delays, there's the potential to also do more trial mining. I'd like to do some anyway. I'd like to do an underground trial. So subject to the board and finances and the engineers and everyone else locally. There's lots of ways. We've currently got material out of the ground enough to produce 6,000 tonnes of anode. So we've actually got the first, over the next few years, we've got enough material to continue scaling up our production. So yeah, there's a lot of positive mitigating factors around that, which give us some comfort on top of what we've seen as a very robust and positive permitting process so far.
Right. Let's talk about Talnode Si. What can you tell us about the timeline of the planned scale up and whether we'll need to build a separate plant like the electric vehicle anode facility in Luleå?
We're currently commissioning a pilot. I've actually just visited it in Germany with along with some customers. It's been fantastic to see. The team there's done a great job and loving what I'm seeing, loving what I'm hearing. So look, I think there's some milestones to go through, but with the pilot doing what it's doing, the next steps would be obviously to finish our feasibility study, which is basically an internal one to prove up numbers. And once we've hooked up a customer that's willing to basically underwrite the demand for the commercial plant, we'd announce some sort of details around that. But I think that the pressure's on to, that's like a 2 to 3 year timeframe to probably be in commercial production, I would say, but it depends. It wouldn't necessarily be in Sweden. We're currently sort of looking in Germany because we've already got that processing know-how, the pilot's there and our people are already there, but it could potentially be somewhere else. But the reasons for being in Germany would be multivarious, which I can only talk about later on. So yeah, it's it's not 5 years away. But it's not 1 year away either. It's going to be. We'll just have to spell out details when it's appropriate. We can't preempt that too much. But yeah, I'm excited that you'd run the pilot. Essentially, you'd run the pilot. In the meantime, you'd be securing a site where you want to go, continuing engineering and design studies, working with the customer, working on the output from the pilot, and you'd basically be ordering equipment, starting to get that ready for commercial production of scale that we'll have to talk about later, in the fullness of time. But yeah, you could imagine that would take a couple of years to be up and running, you'd imagine. But we'll see. We'll talk more about it when we can. But it's pretty. I consider that very near term, considering it's going to be one of the few scalable ways of making silicon anode in the world. Even going to thousands of tons of production would make it, one of the most significant plants outside of China. And once you've proven that, of course, you can just increase the scale massively around the world with the sort of production techniques we use.
Thanks, Mark. Could you please provide an update on the Talnode ship trial?
The ships. Last I saw them, they were heading for Bermuda, but it was the Bermuda Triangle. The ownership of the ships changed, unfortunately. So we were quite close with the former owner of the ships, and we had some access that was then interrupted by COVID. And so, guys, all we could do is see them as they're coming into a port, sort of thing. Now that they've sold the ships and the new owners we've reached out to, we've been in touch, but we haven't managed to get together with them yet. What I can tell you is they have not been dry docked again. So as far as we can tell, the coating's going perfectly fine. You can track these ships. They've changed their names, so they're a little bit harder to track. In future, we hope to still get access to them and publish the results of that trial. But the fact that it's still cruising around out there and the bit of the ship that's got our material on it isn't more rusty than other parts of the ship suggests that it's all going perfectly well. So yeah, I apologise we can't track it down more, but yeah, it's a bit, the new owners have been a little bit harder to sort of get access to. So yeah, look, when we can, we will still provide something for that. We just don't have anything we can say in public about it other than it's out there floating around very successfully at the moment.
Great, thanks. Turning back to the area around outside both Vittangi and Luleå, could you please comment on the status of the region's infrastructure, for example, road, rail, water, power, etc., as it relates to our project?
Up at the mine, was that, or down at the refinery?
Both.
Yeah, they're pretty radically different. So starting at the refinery, the area is local authorities have basically built an industrial park, which is up to them to permit for various things, and we're permitting other things. So this is behind the steel project and the coking coal plant and the existing steel manufacturing plant. So the environmental guys have been permitting things like all the discharge water and things like that. It's on the edge of the Baltic Sea, so it's not in a river as such. So there's benefits to being there. Power we've secured, as far as I know, we've secured an allocation of considerable amount of power. So that's been done. It's being installed. There's lines being run into there that are timed. We've got some power into the site already. It's been cleared, power's on. So the permitting and everything behind that. So there is an ongoing, there's not only building permits, there's environmental permits for the refiner as well. But that process is not like the mining one. It's a lot faster, and we're expecting that to all be sort of resolved. So power there, water discharge, water availability, all those things are all taken care of as far as I know. Up at the mine, there's got to be an extension to the power line put in from Sapavara up to the turn off into the mine site. But in the short term, if there's any delays to that, you've got potential for gas, and short term, you could have short term bullets of gas and generators put on if there's any overlap needed. But power lines being put on there from Sapavara, from the existing line that goes past the project along the bitumen road there. Roads upgrading. What's happening with water? The site pretty much uses its own water, so it doesn't have to draw any really. There's some melt water and groundwater that then gets used and gets recycled. There's a local little lake there that we sort of used as part of the process, so the mine wraps around it, and there's a sort of closed system with an old ice age sand dune that sort of buffers that area from the river. And yeah, it's all part of the permitting process for that. And so yeah, I think that can all come along pretty quickly. It's very clean. I think the actual water discharge is about 1/8,000th of the current water flow going down the river. So it's a bit like throwing 4 buckets into the Sydney Harbour per period of time. So it's a very, very small low impact project the way it's been built. And yeah, to be honest, it's going to be good. We're going to be able to do a lot of things there that start a new generation of technology being applied to mine sites. It's going to be a very modern way of controlling, monitoring and a site and showing how new mineral industries can be done compared to the old sort of copper and iron ore industries of the past. Does that answer the question? Sorry, Alex.
No, that's great. Mark, we have time for just one more question. Would you be able to talk about the purpose of our presence in Japan, please?
Oh, well, originally, our Dr. Capiglio, our senior battery scientist and frankly, wonderful contributor to, Talnode C and the development of that and the process technology. He lived in Japan. He previously worked for groups like Toyota, Panasonic, and lived in Japan. And so we set up some capability there, and we did a lot of work with equipment vendors there, and then have since transferred all of that in-house. So we still have, obviously, Japan is a very traditional market for lithium-ion batteries, high quality materials going into not only their local battery makers, but Japanese battery makers that make things in other countries and other continents. So there's some benefit to having representation there. We also have representation in Hong Kong as well. We have an office there as well with some great people there. But it's something that may or may not be cranked up in future. But predominantly everything's the main focus is mostly on Europe. But that's what Japan was there for. It's been great working with them on some of the high tech parts of what we do in the anode making.
Awesome. All right.
Anything else?
We have that's all we have time for today. So thank you, Mark, for your presentation and time answering questions. Thank you, everyone, for attending. Keep an eye out for our next quarterly investor webinar in Q2 2023. Thank you, everyone, for your time, and have a great day.
Thanks, everyone.